Okay, today is lesson 5, and it's linear word problems. So once again, linear means line, which means one dimension, which means there's only going to be one answer. Word problems are many students' bane of existence. They hate trying to take and translate it, but you've got to think of it like a foreign language. We have English, and we want to translate it into math. And you're going to have to read very carefully, Webbit, when you do this. Start reading, obviously, from the left side and try and make sense of every word that you see in the problem. Okay, so let's pop to it. The sum of a number and 5 more than the number is 17. What is the number? Generally, we get kids who read and go, I don't know. So let's start one phrase at a time. The sum of. Okay, right then and there, in your head, you should know that means we're adding. So I am going to put a plus sign down. I'm actually going to get my calligraphy pen because I like it better. Now, you're generally adding two things together. I'm going to need to put something over here and something over here. All right, let's keep reading. A number. We don't know what that number is. So this is where algebra comes into play. We are going to take a letter and let it stand for that number. You can use any letter you want. I'm going to use N for number. And then generally you often see people write down here a little note. Let N equal the number. Now they call that a let statement. So we always know what N means. It's a number. Kind of obvious, isn't it? And, well, that signifies that we're moving from the first circle to the second circle, because it tells us we're adding the number and something else. Well, what are we adding? 5 more than the number. All right, so now I've got to take 5 more than the number. 5 more means to add, and then the number was N. The result is, okay, well, is simply means the equal sign. And then the last 17. Okay, so there we have a nice little algebra problem to solve. N plus 5 plus N should get me 17. So if I come over here, do a little solving, I'm going to combine like terms. So I have 2N plus 5 gets me 17. I'm going to rewrite this as 2N equals 17. And then over here, I'm going to put a minus 5. Because remember, I'm taking my number and moving it to the other side of the equation. So I do the inverse operation of adding, which is subtracting. So 2N equals 12. N equals 6. See, so the number is N. So I think the answer is 6. So I'm going to check that against my word. Sum of a number, I think that number is 6, and 5 more than that number. Well, what's 5 more than 6? Well, 11. And if I add those together, I should get 17. I do. N is 6. All right. The difference between twice a number and a number that is 5 more than it is 3. Whew. Once again, a long, long sentence. Let's break it down. The difference between. Okay, I'm going to take that and I'm going to translate that into math. The difference between means to subtract. And once again, I'm subtracting two things. Something here, take away something there. Twice a number. All right, so I'm going to do my little let statement. I'm going to say, we're going to let's just use an x this time. Let x equal the number. But they just don't want me to put the number here. They want me to put twice the number. So that means I'm going to have to put 2x. And that signifies that I'm moving to the other circle. A number. Well, we already know what x is, the number, so I guess we're going to put x. That is 5 more than it. It. Who does it refer back to? It refers back to the number. So 5 more than it is, there's my equal sign, 3. Now careful, got a little problem right here, and it's this subtraction. Remember, I'm not just subtracting x, I am subtracting the x and the 5. So when I rewrite it, it wants me to subtract all, not just the x. So that means I'm going to have to distribute, because I want to do 2x minus x minus 5 equals 3. 2x minus x turns into x. I'm going to do the inverse operation, which means this minus 5, I'm going to move to the other side of the problem by doing a plus 5. So I'm saying my answer should be 8. Let's check that. The difference between twice a number, okay, well, that means 2 times my number of 8, so that's 16, and a number that's 5 more than it. Well, what's 5 more than 16? Sorry, what's 5 more than 8? 13. When I subtract them, I should get 3. Great. So 8 was my answer. Okay, last problem for the day. Evie and her father are comparing their ages. At the current time, Evie's father is 36 years older than her. 3 years from now, Evie's father will be 5 times her age at that point. How old is Evie now? Whew! All right, break it down step by step. Gave you cute little pictures. Here's Evie. Here's her dad. And let's take a little shortcut now. We're just going to cross off things as we read them and understand them. We understand that Evie and her father are comparing their ages. Great. Good for them. Guess it's kind of boring in the household tonight. At the current time means right now. Evie's father is 36 years older than her. Okay, we've got some math there. So let's write this down. Who do we know the least about? Evie. We do know that if we take Evie's age and add 36 onto it, we'll get her dad. And yeah, you can call her Evie or Evie, whichever one. I went with Evie. 3 years from now. Whoa, hold on. Now what's going on? Now we're aging them 3 years. So 3 years from now means we've got to come down here and we've got to take Evie and add 3 years onto her and take the dad and add 3 years onto him. So if you were wondering what our let statements are, we let X be Evie's age now. And we let X plus 36 be her dad's age now. That's how we lined them up originally. But in 3 years, Evie's father will be 5 times her age at that point. Here is where it gets a little confusing for kids. If we take her dad, and one of these people have to get multiplied by 5. If we take her dad and multiply it by 5, is that going to equal Evie's age in 3 years? No, we just aged him almost to grandpa age. However, if we multiply and rapidly age Evie, she'll catch up to her dad. And that's what we want to do. This is her dad in 3 years. He's X plus 39. And that age will equal Evie if we rapidly age her by 5 times. Now we have some math to do. Let's move things around. Let's get our variables to one side and our numbers or our constants on the other. This case, let's say, I'm going to move this X over here. And I'm going to move this 15 over there. And when I clean that all up, on this side I have 39 minus 15, which is 24. And then 5x minus x, which is 4x. So I'm thinking x equals 6. And what does that mean? Oh, x is Evie's age right now. So Evie, if we come over here and clean this all up, we say she's 6 years old right now. And that's all they wanted us to find. If we wanted to find her dad's age is 42 right now. But let's go back and make sure we're okay. All right. Evie and her father are comparing their ages. At the current time, Evie's father is 36 years older than her. Yep. 3 years from now, oops, that makes her 9, and that makes him 45. Evie's father will be 5 times her age. Okay, so if I 45 equals 45. All right, so we have another one with age, kids and little cute clip art doing here for tomorrow in class. See you then.